All right, seventh graders, this screencast will help walk you through packet pages 20 through 23 if you would like to use just kind of my extra assistance. Again, you don't have to use the screencast if you don't want to. All right, so I'm going to get started on page 20 of your packet. And at the very top, there is a paragraph that you should read, so feel free to pause the video now if you have not done that. And then I'm going to walk you through this Google Slides presentation, which basically is a set of directions on different videos to watch and pictures to look at in order to learn more about the evidence that a meteor came and wiped out the dinosaurs. As you go, you're obviously going to be answering questions in the packet, and that's what I'm here to help you with, is just kind of explain some things in more detail. All right, so let's get started. So if I advance in the Google Slides, it says that we're going to be reading the instructions on the paper document. So that's your packet. And then you're going to be referring to the correct link that's within this presentation. Everything's in order, and we already have everything in view mode while you watch this. Okay, so just so you know, one thing to be aware of, the Cretaceous Paleogene, which is abbreviated KPG, it's not CPG, which is weird, but it's KPG, just trust me. This boundary that you will see written in this activity over and over again, it has two different names, the KPG and the KT. You do not need to memorize these for the test. You should be able to recognize them on the test and know what I'm talking about, but you do not need to come up with all these letters on your own. So what is this boundary anyway? The KPG boundary, it's a thin layer of soil that's in the ground that has a lot of iridium in it, and we're going to learn more about iridium later. Okay, so just wanted you to know what these letters mean. It's a thin layer of soil, and this thin layer of soil is very, very important to helping us figure out how the dinosaurs went extinct. Okay, so let's learn more about this boundary, the KPG boundary. So let's take a look at what it actually looks like. So this is step one, number one, on page 20 of our packet. It asks us to observe the photograph, the Cretaceous Paleogene boundary, and we're going to do that now. So if I click on this, all right, here it is. So this black layer is the KPG boundary. The pocket knife is here just to give you a sense of thickness. So it's maybe about 1 inch to 2 inches wide, and it's the black portion here. So what's important and what number one says is that underneath this boundary, all of these rock layers are a different time period than everything above. This boundary is an important marker in Earth's history, and we're going to learn more about that. But the area that is above the boundary line is the Paleogene time period, and the boundary below is the Cretaceous. The Cretaceous is time of the dinosaurs, and then the Paleogene above, no dinosaur fossils. So we'll talk more about that later. Okay, so we already accomplished number one just by looking at what we were supposed to. So now we're back to our directions. So now step two says click on the interactive periodic table of the elements, which is right here, and we are supposed to read about iridium. Okay, so here is the periodic table, and I'm supposed to find iridium, and so it's right here in the center. So I'm going to click on it, and now I'm going to do some reading. Now, because you're here working with me, I'm going to bring your focus to the part that would actually be relevant to what we're learning about right now. All right, so it's the fourth paragraph down. It's right here. Okay, so I'm going to read a little bit right here at this point. It says, iridium is found in meteorites in much higher abundance than in the Earth's crust. For this reason, the unusually high abundance of iridium in the clay layer at the Cretaceous-Paleogene boundary gave rise to this Alvarez hypothesis that the impact of a massive extraterrestrial object, meaning something from outer space, caused the extinction of the dinosaurs about 66 million years ago. Okay, so we're going to be done reading at that point. So if I think back as to what I read that was important, apparently iridium is not that common in the Earth's crust, but it's really common in meteors. And scientists found this iridium layer, which I showed you in the previous picture, and it's almost all iridium, which is very unusual. That's not what we normally see in the Earth's crust. So scientists started to wonder, how did all that iridium get there? All right, so now what we're going to do is, it tells me it says answer question 3 in my handout. So if you look at question number 3 on page 20, it says, what does the identification of the element iridium help us determine about what happened at that boundary? So again, if I go back to this picture, having such concentrated amounts of iridium tells scientists that there must have been something there that actually made all that iridium, that put it all there. And because it's in a layer and it's super concentrated, scientists can conclude that this iridium must have come from a meteor. So imagine a huge meteor coming and hitting the Earth. Since it hits at such high speeds, it explodes into tons of pieces, and all of that iridium dust that was in the meteor settles onto the Earth and settles down and creates a layer of iridium, or basically meteor pieces. And so scientists conclude that this layer of iridium came from a meteor that killed off the dinosaurs. And we can conclude that because underneath this layer, scientists see lots of dinosaur fossils. Above the layer of iridium, no dinosaur fossils, which would again make us think that dinosaurs must have been wiped out and went extinct because of this meteor. Otherwise, we should see dinosaur fossils above it. So you might want to pause at this point and write something down for number 3 based off of what I just talked to you about. Okay, now let's move on to the next part. So now it says shocked quartz picture. So now we're going to observe the shocked quartz picture. That's what number 4 says to do on packet page 20. So if I click on this beautiful structure is called shocked quartz. So first you're just supposed to look at it. Ooh and ah, so pretty. And then if you go back to this, here's our definition. It says under intense pressure, shocked quartz will form. The crystals in the quartz flatten and spread out. The picture above shows shocked quartz from a side view. Okay, so that brings us to question 5. What could possibly explain the formation of shocked quartz? Well, if I look back at the definition, it says intense pressure is needed to make shocked quartz. Okay, so perhaps the pressure from a meteorite hitting the Earth could have caused the shocked quartz. And scientists found shocked quartz all over, near and around the impact site of the crater. So I'll give you some time to respond to question 5. And now I'm going to advance to question 6, which says to observe the picture of tektites. All right, so here are what tektites look like. Okay, they're these glassy black objects. They look kind of like obsidian, if you've ever seen obsidian rock, but they're not quite that. Okay, so I'm observing, I'm looking at the picture. And then question 7 on the next page of your packet says, what are tektites and what does their formation suggest about the potential cause of the KPG extinction? So if I go back, you're going to have to read the definition here of tektites. It's a small glassy object that forms from a high impact collision. Okay, high impact collision, probably from a meteor. So scientists found these tektites, these tiny little glassy objects, all around the impact site of the crater, buried deep within the Earth. And those types of glassy objects only form from a high impact collision, which a meteor could cause. Okay, so I'm going to give you time to answer question 7. And then question 8 says, what are 2 pieces of evidence that scientists use to draw conclusions about what happened at the KPG boundary? Well, actually, we have more than 2. We have our iridium layer that we looked at a picture of. We have shocked quartz, and we have tektites. We also actually have a 4th item. We have the impact crater that we found underneath the Gulf of Mexico, I think it's about a kilometer down, okay, the Chicxulub crater. So we have lots of evidence that would allow scientists to conclude that a meteor wiped out the dinosaurs. Okay, so now we're going to move on to part 2, which is called the winners and losers. Which types of creatures won and were able to survive through this huge meteor hitting the Earth? Because obviously not all life on the planet went extinct. And which types of life did not survive? All right, so that brings us to clicking on the Declining Diversity Interactive. It says you might need to allow for Flash Player here, and let's see what ends up happening. All right, so here it says get Flash Player, allow for that. Okay. All right, so question 10 says, where is Hell Creek? And it does say that we will need to research this on our own. The interactive doesn't tell us. And if you Google search, Hell Creek is in Montana. So you can write that down for number 10 of your packet. And now we are to use this interactive. So this is what Hell Creek looks like. It's a bunch of rock layers, but Hell Creek must be important, otherwise we wouldn't be talking about it in this interactive. It must have something to do with the dinosaur extinction. Okay, it says here's a cross section of the Hell Creek site. Each layer represents 100,000 years of time. Choose a layer of rock to get a measurement of the number of dinosaurs discovered so far in each layer. Sorry, I'm doing a screencast. That's okay. Okay, hi. Sorry I'm back. I got interrupted a couple times. All right, so let's see. Where did I leave off? I think we're supposed to click on the different layers. Yep. And look at the dots. And the dots represent all the fossils that were found in each particular layer. So again, the bottom layer is our oldest one. And as I work my way up towards the KPG boundary, I see more and more fossils. And then there are none above it. I try clicking up here. So again, this is that iridium layer that we looked at a picture of earlier. So the question is number 11. Does it appear that the number of dinosaurs on Earth were increasing or decreasing leading up to the boundary? So clearly it looks as though they're increasing. It's like more and more dinosaurs are living on the planet, and there must be a whole variety of them. And then all of a sudden, boom, no more dinosaurs above this iridium layer, which again, we would conclude that that came from a meteor. And since we don't see any fossils above, it must have caused the extinction of the dinosaurs. Number 12 says, what do you observe about the dots above the KPG boundary? Well, there aren't any. So I can conclude that the dinosaurs did not survive the KPG event. All right, now number 13. Let's see here. Number 13 says to click on a video. So we're going to listen to this gentleman, Dr. Kirk Johnson, talk about the KPG boundary. So all right, so now we should be able to answer Number 13, I know the video got a little weird in the beginning where it kind of cut out, but I'll help you with 13.